This video is intended to be a review of the basics of radicals. So first of all, remember radicals, we're talking about roots like square roots, cube roots, etc. So if we have something like the square root of 9 here, we know that that equals 3 because 3 times 3 gives us 9. This is a little different than when we have x squared equals 9 and we apply the square root, because then we have two possibilities. Because when we apply the square root, we need to remember it could either be the positive or the negative root. So we get plus or minus 3, because negative 3 squared equals 9, as well as positive 3 squared equals 9. Be careful with something like the next one. Square root of negative 9 is going to be imaginary, because there is no real number that multiplying it by itself is going to give you a negative. So the closest one you might have here is negative 3 times negative 3, right? But that gives us positive 9, not negative 9. So we cannot have the square root of negative 9 with real numbers. Cube roots, on the other hand, totally okay, because cube root of negative 125 is going to be negative 5, because if I go negative 5 times negative 5 times negative 5, I do get negative 125, right? Because my first negative times a negative gives me a positive, and then my next negative gives me a negative overall. So if I have higher order radicals like fourth roots, again, fourth root of 16, well, 2 times 2 times 2 times 2 gives us 16. So that is equal to 2, but if I have a negative, because it's an even number of, in our radical, right, fourth root, that's again imaginary. In general, if we have an odd number like third root, fifth root, seventh root, we can have a negative, because a negative times itself an odd number of times does result in a negative. If we have an even root, like 2, 4, 6, etc., we cannot have a negative with real numbers. So we are going to have imaginary numbers in that scenario. Just a quick note about that radical sign, the square root, right? There's an implied 2 on that, because it is a square root. Not an implied 1. Another way of saying that is, there's two ways we can show that, right? Square root of 2 with that 2 there, or the square root of 2 without that 2 there. There's also a little bit of notation going on when we change from radical form to exponential form. So remember, if I have x to the a over b, the top part of that fraction in the exponent stays an exponent, but the bottom part, the denominator, becomes tells us which root we have. So that piece, the b, is called the index. The whole radical expression is called a radical. And the radicand is the piece inside the root, so in this case it's the x. So we can flip from radical form to exponential form and vice versa. So if I have the fourth root of 7 and I want to change it to exponential form, that becomes the 7 to the 1/4. If I have the square root of something, well, in this case it's 5, that becomes 5 to the 1/2, because of that implied 2 in there. If I want to look at evaluation, I can switch that so that it becomes the fourth root of 16 to the power 3. So the fourth root of 16 is 2, and then I take it to the power 3, I get 8. I will point out that is not the only way that one can be done, because we could apply the power first and the root second. Generally speaking, that's going to make our lives harder, because we end up with much larger numbers, right? 16 to the power 3 is 4,096. And then taking the fourth root of that, we would get 8, but you'd probably need to make a factor tree in order to work that one out. So it's definitely easier to take the root first and then the exponent, rather than the exponent first and then the root. So looking at slightly more complex expressions, if I have negative 27 to the 4/3, my first step, put that into radical form. Once I've got it in radical form, then I can take that root, right, the third root. It's going to be easier than going 27 to the power 4. So the third root of that is going to be negative 3. I still have that power 4, though, that I need to apply. So negative 3 to the power 4. 3 times 3 is 9, times 3 is 27, times 3 gives us 81. The next one is more involved because there's 2 parts to it. It's a more complex fraction, but it's still the same steps, right? So the first step, take those exponents, write them in radical form. Second step, apply the radical portion, so the third root for the top. So third root of 8 is 2, and the fifth root of the bottom is also 2. See, I missed an equal sign here. And then we have 2 to the power 2 and 2 to the power 3. There's 2 ways you could do this. You could actually do that multiplication and go 4 over 8 and then reduce it, or you could cancel, right? Because 2 of those 2's are going to cancel, leaving us with 1 on top and 2 on the bottom. So whether you go 4 over 8 and then reduce, or whether you cancel to do the reduction at the beginning, you're still going to get 1/2 for a result on that one. So that covers the review portion from previous levels.